because the greenhouse gases are causing warming effect, and how this effect is measured. It is in terms of always GWP, that is called global warming potential. So one should have a knowledge about the greenhouse gases and the related emissions. So the final outcome always we tell in terms of GWP, the global warming potential, because it measures the warming impact. And when it comes to life cycle analysis, and it is not only specific to civil engineers, because there are a lot of engineering parts involved. But when we speak about the civil engineering point of view, we are trying to do this life cycle analysis for any structures, for example, any buildings, because it evaluates the impact over the full life cycle, but specific to civil engineering limitation. But rather than a lot of other engineers also involved, for example, the electrical engineers also contribute, because the building goes into 3-4 stages, because before built stage, and once it is completed, the building, it is completed for usage, it is under in use category. And during the service life, there are a lot of process. Then once the particular service life of the building is going to end, then it comes under the next stage, maybe the end of life. So the life cycle analysis not only particularly specific to civil engineering category, rather than several stages and several engineering point of view, understandings are needed. So for example, as a concrete engineer or civil engineer should know, because we speak mostly about carbon emission when we speak about, because that is one particular component of life cycle analysis, emission of carbon, rather than your energy efficiency or the utilization of waste and cost efficiency. We mainly focus on the CO2 emission. It is the known factor that producing 1 ton of cement, and it releases roughly 0.6 to 0.9 tons of CO2. But this information is specific to ordinary Portland cement. And we know the process of the cement manufacturing, maybe the limestone decomposition, and its further process of producing cement. So we need a lot of, it is the outcome that around 500 to 600 kg of CO2, it's going to be the outcome, and 300 kg of CO2 from fuel. And what happens, it is again, this application is specific to civil engineering point of view. And other than that, we know the greenhouse gases, not only it is CO2, we have maybe nitrogen oxide or methane, whatever it is. So these are all the gases that trap heat in the atmosphere and cause global warming. So in specific to life cycle analysis, this is the method to assess environmental impact of a product from raw material extraction to disposal. So life cycle analysis is a broad term, but it has a connectivity with many sub-terminologies, right from greenhouse gases and different stages of any construction, and how we measure the emission based on the limitation and application, something like the GWP values. So in this stage, everyone should know about the 3 terms called embodied carbon, upfront carbon, whole life carbon. Because one would like to measure or estimate the GWP values, there should be a familiarity about the different stages involved in the construction process, right from the raw material extraction till the possibility of utilizing the disposal case, the building to the new product. So I can able to show in later stage the slides. But these three terminologies one should able to understand. There are some material related emissions are possible for the material whatever we are using before construction or after construction, whatever it is, and that is called embodied carbon. And upfront carbon, it is specific to the emissions before use of the particular structure or building. And the whole life carbon, it is the total emissions. It is considered for the entire life cycle of the building, right from the raw material extraction to the overall disposal. So it is the interest of the people, maybe in application point of view or sustainability analyst or LCA analyst or research point of view, people work in different directions in different categories. So what is the meaning of this embodied carbon? Before we see the definition, this is the popular LCA terminology based on IGBC as well as CAI, and we have ISO standards also. The overall stages can be divided into 4 categories in LCA. It's product stage, construction stage, in-use stage, end of life stage, and we have one more stage called the D stage. Because in product stage, we can see that the steps coming under product stage, extraction of raw materials. If it is the concrete engineer here, the interest is the extraction of maybe the aggregate point of view or cement point of view, the aggregate to produce the particular ingredient that is needed for concrete development. We have the steps: extraction of raw material and transportation, including manufacturing. And construction stage, once the product is being manufactured, there will be a transportation to the site and the construction happens. So it inclusive of A1 to A5. A1 to A5 is called the upfront embodied carbon stage, because this is the important stage, because we have to concentrate more on this upfront embodied carbon, because once the building starts its functionality, we cannot go back and we cannot change anything. That is a very difficult task. So it is better to look into this product stage and construction stage. That's what the new code developments and the literatures give so many ideas about what we can do best to improve the life cycle performance of any building during A1 to A5 stage. So that is called upfront stage. And the in-use stage, it is of several process. It includes use, maintenance, repair, replacement, refurbishment, and we have operational energy, and it consists of the mechanical, electrical, plumbing, air conditioner, chiller unit. We have a lot of systems coming under operation energy, and there will be operation water. Example, in case of any a huge area, maybe a commercial buildings or industrial building, we have operation water. It includes, we have wastewater recycling plants, we have effluent treatment plants. So we have operation water also, and we have an end of life stage that is called stage C. For example, after 70 years or 60 years, once the durability is completely over, then if it is coming under demolition stage, then there will be a transportation of waste and waste processing and disposal. And there is an addition of another stage called stage D also. I have not added here because once the proven results, someone can able to identify a product out of this disposal that can be recycled, then you are sure about the circular economy you can able to develop. Then the stage D also can be added. That is the added advantage. But whatever you calculate this GWP from stages of A1 to C4, that can be compensated with the help of stage D. So now this embodied carbon, anybody can able to understand the total CO2 emissions from material production, construction, maintenance, and end of life. So all together, it is called as the embodied carbon. Does not include operational energy. There are some rare cases people used to add with inclusive of this operation energy and operation water also. Upfront carbon stage, it is completely A1 to A5 according to the chart whatever I have shown. And it is emitted CO2 emission before the building is being used, and it is the combination of materials, transport, and construction. The whole life carbon stage, it is the total carbon emissions over the entire life cycle of a building. So it inclusive of A1 to A5 U stages and end of life carbon C stages. So, so now it is the key takeaway for anyone to know product stage, construction stage, in use stage, and end of life stage. And at the same time, so what are all the combinations coming under upfront embodied carbon? Or what do you mean by embodied carbon? What is the end of life stage? What we mean? And what is the whole life cycle carbon, and specific to operational carbon or operational water? So this is again the basic terms to know why or in what terms of we measure this GWP and what is the exact outcome, how we represent this. So to know if it is 1 kg of methane, the equivalent amount of production of CO2 emission is 27 to 30 kg carbon dioxide emission. So 1 kg of methane has the same warming effect as 27 to 30 kg of CO2 over 100 years. So it is something like a neutral value. We consider CO2 as a base. With respect to CO2, we just measure the remaining or whatever the material you would like to measure the emission to calculate the GWP values. So here, the emission factor, I can show it in subsequent slides, that becomes a important role here. So one of the code called the guideline sustainability of construction works methodology for the assessment of performance of buildings. The same whatever I have earlier shown, the product stage, construction stage, use stage, end of life, and here you can see the stage D, whatever I have mentioned earlier, the supplementary information relevant to benefits and loads beyond the system boundary. This is the area in which one can able to prove that the circular economy of the particular building is being satisfied after the successful recycling of the demolition, whatever the material, example, recycling of the concrete or recycling of steel or any other materials. So what is the connectivity between this, our SDG, Sustainable Development Goals, specific to LCA, Life Cycle Assessment? So there are 4 goals. I can able to connect it. It is 12, 13, 6, and 9. But one can able to correlate what is the exact connection, in what way the particular goal is being affected on, or what way it can be enhanced, the life cycle assessment and the sustainability can be enhanced. So it starts from SDG 12. It is responsible consumption and production. Those who are working in especially the concrete or construction methods, can able to correlate so many examples for responsible consumption and production. And climate action, that also have a good correlation and connection, especially for civil engineering point of view. And clean water and sanitation, again, it has a well-defined connection. Industry, innovation, and infrastructure. So I will show later how it is being connected, and we have a specific impacts as well as certain modifications are needed in our day-to-day construction activities, so that we'll have a better attainment of these SDG goals by better life cycle assessment. And whatever I have shown here, the same SDG. And this entire process, overall life cycle assessment, start with so the overall life cycle assessment, whatever earlier explained, the same, right from the resource extraction to material processing. But the according to your interest or your practice, this process can be modified little bit extra, and it can be fine-tuned with subdivisions also. It is not only specific to concrete alone, and the transportation use and end of life and again being recycling. So here, the building life cycle, whatever I have shown here, it can be again given in terms of embodied carbon. We have operational carbon, and again embodied carbon, it is completely the total, overall we call it as whole life carbon. So in this case, there is a important stage called embodied carbon uplift stage, whatever I have told. It is around 20 to 40% emissions we can able to see. And in operational carbon stage, the emissions are, this is some approximate percentage only. However, it ranges between 40 to 80%, including the maintenance emission 10 to 20%. The end of life has less than 5%. So before we move to next terminologies, there are three types of terminologies I would like to introduce here. One is cradle to cradle approach. Yes. So here, if someone is interested to go for a life cycle analysis process, there are three stages, whatever we have already seen. It can be again connected with these three methodologies. The approach is cradle to gate type, and cradle to grave, and cradle to cradle type. And just remember the same methodology, whatever we have seen earlier. The emission stages A1 to A3, it is coming under production stage. So that emission stage is connected with cradle to gate approach, because the particular product is being manufactured and it is being delivered till the gate of the factory. So this cradle to gate approach limitedly applicable till A1 to A3, and the carbon category coming under is upfront carbon emission. That's what we have seen earlier. What it represents exactly, the carbon emitted before leaving the factory, because it is not being utilized or in use stage. And example in concrete slab, the cement making process or aggregate processing or batching, whatever it is. And in cradle to grave, it is completely from A1 to C4. It inclusive of all the product stage and in use stage and end life of the stage. So the carbon category is something like whole life carbon, because it is the addition of upfront, in use, and end of life. and what it exactly represents the entire life from extraction to disposal. So people's interest is different according to the project or maybe the research point of view. One can able to choose the cradle to gate study. There are a lot of scopes, and cradle to grave type also. And cradle to cradle approach, it has the emission stage. We have the advantage of taking stage D here, though we consider A1 to C4. If we have a proven product for recycling and we can able to give better circular economy out of that, the D is contributing here. So cradle to cradle approach, we have that addition also. Here the whole life with recycling benefits can be ensured because the product returns as a raw material and it forming the new cycle. So it is a very recent area. And slab crush, example, slab crush to recycle aggregate and steel being reused. So that's what shown in here as a cradle to gate approach, the first three process, and starting from the end, it can be considered for cradle to grave approach. And once it is proven for recycling and remanufacturing or reuse, then it is coming under cradle to cradle approach. So this is the same definition we have already seen. So before how we give a better results, usually the breakup or the outcome will be like this, because someone is interested in LCA process, we should know what is the input and what are all the connected activities and what is the outcome. So in this case, usually the working sheet breakup will be like this. For example, if you are taking a complete building or a particular element, so which element it belongs to and in which stage you are interested in being calculation and the respective global warming potential, and it can be again converted to per square meter area also. So for example, someone is interested in particular element or single floor or maybe a entire building. So it can be worked out like this. So let me show one breakup uh, case here. I hope the Excel sheet is visible, right? I'm showing a sample sheet here. So here the element breakups are given. Example, it consists of several foundations and floor constructions with many elements, which stage is being considered and the corresponding emission kgCO2 equivalent values. And this is the summary, maybe for a overall building, floor wise, element wise. We can able to see the different stages, what is the GWP values, right from A1 to C4. So it doesn't mean that all the elements or whatever the particular description, whatever you have taken, should not contribute in all the stages. There are some applicable stages, there are some non-applicable stages also. So the final outcome will be like this. Someone is calculating element category for a particular building. A1 to A3, what are all the GWP values as element wise? It inclusive of A4, A5. Here I am not interested in calculating B1, B2, B3, B5, B6 because not relevant to civil engineering point of view. But anyway, it is the contribution of many engineering professionals. So once it is being calculated, then we can able to categorize it according to our requirement, because we have got split up of stages like uh, total whole life carbon also. so that we can work in stage D or for further improvement. So this will be helpful to this breakup will be helpful to analyze the exact effect of GWP on the product efficiency. A product system or process throughout its entire life cycle. So majority of the people, the outcome is the whole life global warming potential because it starts from the raw material extraction to end of life, and the whole life embodied carbon, that's what I have already explained, and product stage also explained and upfront. So here I am giving the answer for whole life. For example, the final outcome value will be like this because it inclusive of the stages A1 to A5, B4, B6, and C to C4. The estimated whole life embodied carbon, excluding B6, I would like to know this much GWP, and if I divide with floor area, this much kg CO2 equivalent for per square meter. And now we can able to compare the contribution, what I said, based on material point of view emission or process point of view emission or operation related. So we could able to compare the percentages also. But this B6 stage, it is the top high impact category in new stage. The operation and energy and operational water are coming under in new stage. And these are all the exact issues like heating, ventilation, and air condition, lighting, water heating, refrigeration, pumps and fans. Maybe in the industrial buildings and commercial buildings has a lot of impact in this stage. So another particular terminology one should able to understand is environmental product declaration, because to calculate GWP value, definitely we need this um, emission factor, because the emission factor is going to vary because there are a lot of dependent parameters in emission factors. The emission factors are changing product to product. One can able to calculate the emission product with our own understanding also, or it can be referred from any literature, or there are a lot of guidelines are available. There are some standards also available. There are many softwares also giving these EPD values. This is the standardized and independently verified document. Reports environmental impact of nowadays. A lot of even manufacturers are giving this emission factor value so that we can able to understand this the what is the exact sustainability of that product. It's based on principles of international organization. And what is this exact EPD includes? It is a data sheet. It has got raw material extraction, water consumption, emissions data, waste generation, and end of life disposal or recycling details. So what is an emission factor? This emission factor is it is calculated using the basic formula total emissions divided by the unit of activity. For example, for a concrete engineer to simple to understand, someone is interested in GWP calculation, the unit is kg CO2 per kg of cement. And if it is electrical related emissions, then we tell kg CO2 per kilowatt hour for electricity. Maybe transport related emissions also available. For example, fuel-based emission factors used for fuel, because in all the raw material extraction and transportation process, we have the utilization of diesel or any other fossil fuel. So in case we use diesel or petrol, whatever it is, the kg CO2 per liter value is 2.6 to 2.7. And how it is being utilized in GWP calculation, you can see in the coming slides. And electricity emission factor also equally important. It depends on how electricity is being generated, and it may be a coal-based type or renewable-based type. So here the unit will be like 0.7 to 0.9. These are all the some samples, but it is not. It is going to vary based on specific type of project and dependent parameters. Example for material-based emission factors, for example, cement 0.8 to 0.9 kg CO2 per kg, but it is not a constant value. If I am using ordinary Portland cement, it is different. Slag-based cement, it may be different, and pozzolanic added cement, PPC, it will be different, or geopolymer-based cement, it will be different. For steel and concrete, the values are like this. In case of concrete production, for example, I have a cement emission factor with OPC value 0.9 kg CO2 per kg of cement. In case I'm going to use M20 concrete, I'm using 300 kg, then the final value will be 270 kg CO2 equivalent. So the total carbon emission, it is the combination of process, fuel, and electricity. So altogether it will be added and it will be used for the analysis. So there are a lot of things related to. These are all some of the standards and methodologies can be referred related to ISO standards to know about frameworks of LCA and environmental performance and energy management. So to perform this cradle to gate approach or cradle to grave or cradle to cradle approach, there are a lot of open source softwares are available with some limitations. Like one-click LCA, it is the famous software, and there are a lot of analysis being used with the help of this one-click LCA, because the advantage is the emission factors for different product, it is inbuilt, the APD values. Some of the softwares we have. So here, what is the connectivity with climate impact of buildings, specifically for civil engineering? Here, the buildings contribute to 30 to 40% of global CO2 emissions. So that is the major factor here. And concrete is the major contributor due to cement production. So that's what we are specifically interested in: concrete, steel, brick. So that utilization and the relevant product as well as process till the end of life. Other than that, you have the remaining operation like mechanical, electrical, plumbing, and operational other carbon emission related activities also. So finally, it is high embodied and operational carbon. So whatever we speak, the finally how the improving LCA through material and construction methods. So that is going to be the important, because this is again connected with IGBC certifications and getting some rating for a particular building. So the first one is sustainable materials. So everyone knows there are a lot of research people used to do the possibility of using recycled materials and choosing low carbon materials, because even the revised Indian standard, it is IS 456, it is under being revised, and soonly we are going to get the new 456 emphasize on durability related designs and using low carbon materials, because utilization of slag based cement and we started using almost 50% of slag replacement. The revised IS 10262 gives the optimum content also, and utilization of pozzolanic based cements also, using geopolymer concrete for precast products. So like that, this process can be better enhanced. So preferable renewable resources, locally sourced material also will be contributing. And in terms of construction practice, though there are some in hesitance of using precast, it is advantage for life cycle enhancement for prefabrication or modular construction, since it is reducing the waste and there is no plastering required, because in conventional type we use unnecessarily the plastering. There is a lot of waste of cementitious material again. There is a lean construction techniques, energy efficient methodology, appropriate usage of BIM. And finally, design strategies. It is in every civil engineering point of view, we have it in hand. Design for durability and design for disassembly and reducing material quantity. So though these words are simple, but all the wordings are powerful here. Example number 3, the design strategy itself going to be the biggest contributor in life cycle assessment. In case of the last line, reduced material quantity without compromising strength. Someone is designing for M30 concrete. It is very important to use optimized cement content for your target strength. So right from giving the cement content and partial replacement of possible pozzolanic material, the better life cycle enhancement starts. Other than that, coming to durability point of view, if someone is not familiar or interested in durability related design, we are fully concentrating only in strength related designs, like providing appropriate sizes and reinforcement. Again, we could not able to achieve the better life cycle enhancement, because it is again a waste of cost and energy as well as carbon emissions. Because if I don't use the appropriate grade of concrete for the particular exposure condition, I'm not able to plan the water cement ratio, minimum cement content, then cover. So like that, lot of interrelated uh, parameters which is directly connected with design for durability, then we are missing certain things in enhancing life cycle assessment process. And exactly speaking to SDG 12 and 13, the exact problem is utilization of OPC natural aggregates, resulting embodied carbon and limited recycling. The possible utilization of mainly the clinker, as much as the utilization of clinker, the higher the emission, and this can be overcome by these low carbon materials, recycled materials, and efficient design. What exactly the SDG 6 is connected? The problem is excessive freshwater use, conventional curing methods, untreated wastewater discharge. Even the I hope the revised guidelines in IS 456 prefers the treated sewage water based on your PCB guidelines. If it is being certified, you can able to use it for curing and preparing the concrete. So here the improvement is water efficient concrete, like use of admixture, appropriate admixture to reduce water demand, and optimum mix design. And alternative water resources like recycled or treated water. What exactly SDG 9 connected here? It is the conventional construction practices. As I said earlier, uh, avoid plastering or use precast method. These are all going to be the future trends, like using advanced materials. So the combination of pre-stressed based precast with high strength concrete nowadays being preferable, and self-compacting concrete and geopolymer concrete. There are some smart technologies to improve the performance by some innovation for a particular building, like a green building and smart building. The possible places people can use 3D material, nano materials also, wherever it is being needed. There are some small efforts can make some bigger uh, changes in this life cycle enhancement. And for conclusion, some points I would like to enhance, I would like to cover here. It is deemed to satisfy rules. Those who are familiar about the deemed to satisfy rules, it is governed in many guidelines, many code books. For example, in IS, the deemed to satisfy rules are related to durability is right from cover, minimum grade of concrete, minimum cover, maximum cover, as well as uh, minimum reinforcement, maximum reinforcement, minimum cement and maximum cement, admixture utilizations, and optimum water cement ratios. If someone is familiar and good enough to practice this, then the deemed to satisfy rules are being covered and better sustainability can be achieved. So that will be the biggest advantage, and it is going to contribute in both production stage, in new stage, as well as the end stage. And it is being followed by design for durability norms. That's what I have mentioned here. And ultimately, by following this, there will be no corrosion. For example, in India, if we take most of the building, there is a corrosion because of the deemed to satisfy rules are not being followed. That is exactly again, it is being uneconomical, and you are if the service life it is expected 60 to 70 years, then again you have to go for yearly repair, yearly rehabilitation or retrofitting. Then it is spoiling the um, life cycle enhancement point of view. So there will be a waste of cost and energy as well as carbon emission. So no carbon and less cost energy efficiency combination will enhance the life cycle performance of the building. And in the new code, and people used to give more preference to if you are good in defining your grade of concrete, then there will be a durability also. We can able to tell the durability of the particular building is 60 or 70 years. So this will be the future trend. Maybe someone is constructing, then M30 D70 or M30 D20 120. So the life period of service period of the building also will be combined if someone is good in this durability design. And the final responsibility is durable and resilient structures, climate resilient materials by reduced maintenance needs. So we have the experience of investigating many buildings with the help of non-destructing methods, because this itself contributing in Indian economy, because there are a lot of um, insufficient planning and construction and design. A lot of corroded buildings. Randomly, we can see that in public buildings and residential building, commercial buildings. Um, there are a lot of reasons behind this that can be discussed in some other uh, title. So we can see this type of corrosion cracks, and if we cut any bar, then insufficient yield strength. So there is a lack of life. If the building has to survive for at least 70 years, during 30 to 40 years in between, we should be in the stage of repair and rehabilitation. So the reason may be so many, maybe a carbonation or chlorination or improper waterproofing, whatever it may be. So this is the case study. It is exactly connected with life cycle assessment, because directly you cannot able to go for life cycle assessment unless you don't know the reality of the building, how it is being designed and how it is being performed. Then you cannot directly incorporate a particular case with life cycle assessment. So here, this is the exact problems I would like to show. In all the most of the roof, we see the dummy column. There is no proper structural concrete. The reinforcement starts from here. And there is a possibility of going for geopolymer concrete and no clinker concept, at least for small buildings, whatever the possible manner. So we could able to construct a geopolymer based cementless concrete block with the CSR fund that I would like to show here. And So these are all some of the introductory way of thoughts. If you have any clarifications. I hope I am audible, right?
Yes, sir.
So I have some questions here, so people can answer just to refresh you to whatever we have seen. Just 5 minutes can take based on the slides, whatever I have prepared. And can LCA be used to assess environmental impacts of building retrofits? Any specific answers? So here the LCA can account emissions during renovation and refurbishment also. So over 60 years life of the building, which of the following is the biggest contributor to carbon emission? Biggest contributor.
Energy usage.
Yeah, energy usage. So though we are mostly concentrating on civil engineering based material, energy usage is going to be the biggest matter. And the following is an emission reduction strategy. Emission reduction strategy out of 4. So the implementation of energy efficient technologies contributing more here. And the following is an approach to reduce environmental impact during construction. During construction. Because the IGBC guidelines are connected here, use of local materials, it is very good. Always need not plan for clay brick. Immediate mindset may be clay brick, but we have alternate type of bricks also. So which of the following standard cover LCA studies and LCI studies? So ISO 14040, it is a very good ISO standard. And which of the following are induced as the upfront embodied carbon in buildings life? So I have told earlier only about upfront embodied carbon. It is manufacturing, transportation of products, and construction. What are the different stages of life cycle considered to establish carbon footprint? Different stages. So the B is the familiar term, right from product stage, construction stage, use stage, and end of life stage. So to reduce the total negative impact, you have to note this word, to reduce the total negative impact on the environment, which approach is recommended? So cradle to cradle approach, that is the longest cycle in which you have to work for a better recycling product. Then global warming potential equivalent represents what it actually represents. It is the weight of carbon dioxide that has same global warming potential as the cumulative weight of greenhouse gases emitting during an activity. So that is B. A unit of kg carbon dioxide per kg emission is used to express exactly, it is the material emission, so carbon emissions. And which of the following is not a part of India's commitment at COP guidelines? So you can refer this. This is interesting. And by 2030, 50% of the energy requirement by renewable sources. We'll see whether it can be achieved. And the impacts of climate change can be categorized into environment impacts, health impacts, and economic impacts. An EPD database enables you to, the EPD database, it is the access of the LCA data of specific material produced by the specific manufacturer. And a data set should preferably be obtained from one uniform source so that your result will be acceptable. And what is the unit of measurement global warming potential? What it denotes? It is kg CO2 equivalent. And which of the following is not environment impact category? It is not coming under eutrophication potential. LCA study can be adopted to create discipline in design approach. So embodied carbon is the result of demolition of buildings and recycling of materials. Global warming and ozone depletion are indicators of environment effect. So while performing LCA, why is it important to engage stakeholders in the early design process? Because it is important to work all together as a team, right from architect to construction engineer, because you have to optimize the building design. And which of the following measures can help to cut buildings embodied carbon? Only the embodied carbon. Which measure will be helpful? So use low carbon structural materials and sustainable product as much as. So under building life analysis, manufacturing is addressed in user stage. And in the building life cycle analysis, end of life cycle does not include deconstructive and demolition. So a standardized document informing about product environmental data is product environmental footprint. So another term is here, product environment footprint. An EPD database enables you to design for energy efficiency in a building. So what is the basic but most important input for LCA study? Carbon emissions in kg CO2 equivalent. That is very important. Which conventional construction material used in commercial building by typology? It has insulation.
Hello, sir.
Yes, you have any clarifications?
Thank you, sir, for the valuable session. If the participants have any doubt, you can unmute your mic and ask now.
During the LCA analysis, you had mentioned about, during the questions being displayed, you had mentioned about the LCA considered is from the product to the end. Sorry, recycled. Why is it not started from the mining part itself? Because every product need to be manufactured. So a refining process will be there, the manufacturing process will be there. Why is that part not considered in the case of the LCA of buildings? So that should also be taken into account. No, the lesser the carbon emission of the product cycle, product manufacturing steps, the more will be more will contribute to the circular economy.
Things if we leave, then we blown out of ocean. So we give places for that. So
Yes, it is
I
being
think everybody will
considered
cooperate.
because
Thank you very much.
it depends on the product type. When you go for a concrete, it can be subdivided into ingredients like cement and, say, example, aggregate. These two are the most contributors. But in both the cases, cement manufacturing or aggregate manufacturing, if it is the cement manufacturing, the upfront carbon calculation, it starts from raw material extraction, maybe a limestone or whatever may be the raw material used for the process of the manufacturing of cement. Similarly, for aggregate also, it starts from the quarrying, blasting, and further it is being transportation and other process. So definitely all the uh, product stage related emission values should start from the zero level only. But mostly the values, if you have a specific type of project, if you have a well defined data related to material, distance, and all the cost, we can able to calculate. Otherwise, we can depend on manufacturer or EPD data sheets also. But not for all the material from the raw material extraction, maybe some other than civil engineering materials. There are some manufacturing based materials. The engineers doesn't know the background, so that the product manufacturer data can be taken, but in that date, the source will be missing. That's all.
Any more questions? I hope everything is clear. Now I invite Dr. Vinci Verghese, Associate Professor, Department of Civil Engineering, to kindly deliver the words of thanks. Ma'am, over to you.
Respected Dr. Anand and dear participants, I am very honored to extend the vote of thanks to Dr. Anand, Associate Professor and Head, Department of Civil Engineering, Karunya University. Dr. Anand has given us a brief overview and detailed explanation on the various approaches of life cycle assessment, the steps involved, and the at last summarizing the considerations that that one should incorporate. And he concluded by saying that if someone includes life cycle analysis in detail, this could improve the efficiency of the building, and also it will help in increasing the durability of the buildings. So thank you, sir, for a very informative session. It was a good introduction to our next session as well. And also, among your session that I really enjoyed was that you summarized by selecting certain questions and giving the answers for that questions, which covered your session. And this could help all the participants to have a brief review on the 1 hour long session. So thank you for your approach. Thank you for being with us and sharing this information. Thank you, sir.
Thank you. Thank you for giving me the opportunity. Thank you.
Thank you, sir. Thank you, ma'am. Now, as we move forward with the today's session, it is my pleasure to introduce our next speaker, Mr. Sharavanan Jayabharati. He is a certified Open LCA trainer and qualified Eco APD officer, currently associated with Carbon Figure Academy and National Institute of Technology, Warangal. He is a civil and environmental engineer and an LCA APD consultant by profession, with a strong expertise in life cycle assessment, environmental product declaration, and green building concepts under IGBC, LEED, EDGE, and WELL frameworks. Today, he will be delivering a session on LCA tools, software, and modeling. We are delighted to have him with us. Sir, I warmly invite you to take over the session.
Thank you for the introduction. Let me share my screen. I hope the screen is visible, right?
The screen is visible. Your audio is a little bit low.
Is it fine now, ma'am?
Yes, sir, it's okay.
So good afternoon, everyone. Thank you, Professor Varghese, sir, for this kind of opportunity. And in this session, we will be talking about the tools and software for the LCA. Right. So I hope you people have really a good introduction about the LCA in the previous session. So on top of that, let us proceed further. Right. So this is all about myself. All these are my green credentials. I run Carbon Figure Academy, through which I offer courses on LCA at both the product level and the building level. And I also extend the services as a consultant for doing LCAs and PCF studies and EPD development. And this is what's happening in Carbon Figure Academy. So this is the geographical footprint of the students who have taken the courses from Carbon Figure Academy so far. And I also run that YouTube channel on the same name, through which I post on a regular basis about the important topics on LCA. And this is all about the session today. So we will get to know about the tools. But before that, let's talk about little on life cycle assessment and ISO framework. Then we would get to know about impact measurement as a very broader perspective, how it is being approached. And slowly we would jump into the tools version. So how a tool is typically designed in the market so as to assess the impact measurement. And eventually we will get to know what are the different tools are available. And finally, we will have some demonstrations of certain tools, right? So the context is, very broad by nature. So we have been witnessing a rapid change in the job market landscape, especially since COVID, right? So afterwards, a lot of things have shifted, and people have started changing their interest from core engineering towards application-oriented engineering, like AI, ML, and all those things. And slowly, now people have become optimized. Okay, it's not about learning the AI, ML, but it's all about utilizing that AI, ML in all the existing fields, right? So from that perspective, we can able to see it here as per World Economic Forum. So they have mentioned, okay, which particular jobs are going in a rise by 2030. So we can see environmental engineers at number 12. And by the skill, we can see environmental stewardship at number 10, which is speculated as mostly growing or fastest growing skill set. So when we say environmental stewardship, it's not a particular or individual skill. It is a collective skill set along with some leadership quality. Okay, so no matter wherever you belong, You may be a student, you may be a R&D engineer working in a company, you may be a consultant, and also you may belong to various sector, agriculture, finance, manufacturing, production, anything, right? So no matter who you are or where you belong, how you can relate your action, your matter of activities with respect to the environment, and how you can relate them, how you can measure them, and how you can quantify them, and finally how you can mitigate them, right? So all these put together, we can call it as environmental stewardship. So for example, now you people are mixed from, background like students, research scholars, faculty, and, maybe some working professionals as well. So how your mode of actions, what you are doing, whether you are operating in a company, or you are providing some consultancy, or you are producing some product, or you are simply traveling as the nature of your job. So whatever the activity, how that activity impacts the environment, and how you can visualize that, how you can measure that. That's all it is, right? So that is what environmental stewardship as a very broader perspective. So from that, we are jumping into the directly the measurement, right? So because we have established the context, we all understand, okay, we belong to a particular engineering department and we are studying a lot of concepts on that. Okay, how the impacts of construction, extended towards the environment, and how we can measure that. So in that perspective, life cycle assessment tool is being a fundamental phenomena for the environmental impact measurement as a as a global perspective. But from the market perspective, when we say sustainability, people think, okay, the sustainability only belongs to construction, right? Am I audible? Am I audible?
Yes, sir.
Yes, fine. So, yes. So in case if anyone have a query, please unmute and directly ask. I cannot check the chat box here. Right. Fine. So from the point of view of sustainability, many of the civil engineering professionals may think it is only with respect to the construction. Okay, how green my product is, how efficient my process is. Right. But the sustainability is a very broader phenomena, and within which we can put into or stuff in lot of concepts like eco-labeling, eco-design of products, and sometimes ESG reporting and all everything, right? And very importantly, GHG accounting. We used to say carbon footprint measurement or GHG measurement, right? But personally, I feel LCA skill is a big fish in the ocean of the sustainability. Why? Because once you learn LCA, right, the concept of LCA, when you learn it, you can relate yourself very easily with all other elements or all other segments of the sustainability phenomena, no matter where you go or in whatever the sector you want to work. So if you know the LCA, then you can confidently relate and conversate in the discussions, right? So that's the personal perspective, and you can take a lot of from that. So in case of our particular topic, we are going to talk about the LCA tools and software, right? For that, we have pretty basic brief introduction of LCA. So LCA is what? Nothing but a data-driven methodology used to quantify the environmental impacts. So when we say environmental impacts of what? It can be of a product, it can be of a process, or it can be of a service also. Because many of the times people may think LCA is only meant for product. No, it's not only with the product. We can go for a process and we can do it for a service also. When we say service, what is that? For example, if you are running a cafeteria, you can do LCA for that cafeteria as a service. Really, right? So you can put a system boundary, you can measure what comes in, what goes out. That's your activity, right? And you can do the LCA out of your service. And when we think LCA as a tool, No, it's not about predicting the future or prescribable impacts of a product or so on. But on the other hand, it provides a snapshot in time. Okay, at this point of time, uh, within whatever you have consumed within your system boundary, for which this is the impact. That's all. Okay. So what or how it may be helpful? So it will be very helpful in trade-offs across the life cycle stages. So what is meant by trade-off? Because we have life cycle stage, everybody knows is the typical life cycle stage for the LCA assessment. So we have raw material extraction as a stage, production as a stage, packaging distribution as a stage, downstream logistics as a stage, use and maintenance, and finally disposal, and thereafter some recycling. So everything is as individual stages. So when you do or when you perform LCA for covering all these things, you would understand where you can really react or where you cannot react. For example, you take distribution, okay, downstream transportation. In life cycle modules, it will be called as A4, downstream distribution. Okay, so the downstream distribution is not in your control. You cannot change anything in that thing, but you really understand the downstream impact comes around some 300 kg of CO2 equivalent as a global warming potential. So, okay, I understand that's a very big number, 300 kg, but I cannot react there. Whereas I can look into other areas. Okay, let the downstream transportation be the hotspot, but let me focus on any other area because in that hotspot, I don't have a control. So that is what trade-offs, industrial trade-offs. So you understand some 4 different options and you voluntarily or knowingly let one area to bleed. Just to compensate that, you focus on the other area because that bleeding area is out of your control. That is your trade-offs. So for that trade-offs to be well executed, the LCA as an analytical tool is a very promising, right? So from the framework perspective, ISO 14040 and 14044 is the anonymous stuff, right? So how it got evolved over the time in earlier 1990s. So it was like a 3-step framework, like only the analysis in inventory and improvement analysis. So they did not say impact, they used the term improvement analysis, right? Then it got evolved over the time. Then they put some centric behavior. Okay, around this centric item, our assessment or improvement should be there. That's how it worked. Then finally in the 1996 and further amendment in 2007, ISO came with a 4-stage framework. So goal and scope definition, life cycle inventory, life cycle impact assessment, and life cycle impact interpretation. So sometimes people say life cycle inventory LCI, life cycle impact assessment LCIA. Okay, what is the difference between LCIA and LCA? So LCA is a overall methodology, covers 4 different elements, right? So LCI, LCIA, LCII put together, you get LCA, right? So since 1996, then it got amended in 2007. Since then till now, and I can say forever hereafter, now this is the same framework which is going to exist for the LC, right? So as a consultant or as a practitioner who wants to perform LCA, you just need to learn what is given in ISO 14040. So that's a document of some 11 to 15 pages. And after reading that, you would understand what these 4 stages really indicates. Okay, that is the prerequisite kind of thing. Once you read this, you need to go into the detailed guidelines. So that is given by 14044 ISO. So that will be around some 80 pages document. So if at all, if you want to learn or kickstart your LCA journey, no matter you are a student or research scholar or faculty, because I am very much aware that these days, no matter to whichever journal you want to submit your article, they want you to perform LCA, right? Any environmental assessment, authorized environmental assessment. So LCA is inevitable for all the stakeholders. So learn these two documents. So 14040, you cannot, pirate it from the internet. But 14044, Indian government has launched its own version. So that will be available in the Google for free. So please take that 14044 and download it, take a printout of it and read it. Okay, and understand it. That will give you more enough understanding and information than attending any simplified free courses which are available online. Right. So for the sake of certificates, you may think, okay, let us attend this course and that course. But everybody would talk about what is given in that 14044. So if you don't want to spend much cost and time, you please prefer reading 14044. Right. So impact measurement. So when we say impact measurement, we have approaches or we have perspectives, right? Especially belonging to a construction profession, we have certain types or classifications which are not coming for any other sector. So if at all, if you are belonging to electrical department or electronics or any other, production sector, you don't have this kind of classification. But since you belong to a construction or civil, you should know about these perspectives, right? So first, we have the perspective of measurement of the impact, either on the basis of carbon or on the basis of a full set of environmental spectrum, right? So when we say carbon footprint as an impact measurement, it will be about only a single indicator, GWP, okay? And it will answer how much does this contribute to the climate change, that's all. Okay, so what are the standards are available? ISO 14067, GHG protocol and PAS 2050. And they are very faster. You can find lots of free and open source online tools, and in the name of carbon calculators, you can make use of it. And the result of carbon footprint will pay the path for your full level LCA. So that's your entry level. On the other hand, when you want to understand the impact measurement as environmental footprint, it's a very broad one, multiple indicators, mostly 15 plus indicators will be there, depending on the life cycle impact assessment method you want to follow, right? And it will answer what is the full environmental burden of your product or process or service, right? So for which the international standards are ISO 14040 and 44. So that's for a global standard. From European standard and American standard, separate guidelines would be available. Like for Europe, we have 15804. On the other hand, for America, there is a concept called ASME. Not ASME. There is an organization which normally does quality certifications in America. ASCE is for civil engineering. Something would be there. Suddenly it's not coming. So America have their own set of standard, and Europe has its own set of standard. So globally speaking, okay, what about for India, sir? So we have anything for India? No. So unfortunately, we do not have any Indian specific standard for LCA. So we simply follow either European standard or American standard. So that's what the reality is, right? And slowly, people are developing their regional specific databases for carrying out the regional specific LCAs, right? So that's the very, very broad perspective for impact measurement. Either you want to do carbon footprint measurement or you want to do environmental footprint measurement. So now we are civil engineers and belong to construction sector, right? So we have another perspective, level of impact measurement. So how you want to approach this, whether you want to do the impact measurement for a product or for a building, right? So you can do both. You can do carbon measurement, environmental measurement for product, carbon measurement, environmental measurement for building level also, right? So the roots are like this, right? So now I hope you understand when we talk about impact measurement, these are the layers underneath. Okay. So for example, in undergraduate or postgraduate or even in PhD, especially who people are working in sustainable construction material background. Okay. So they take a product, okay, mostly the concrete. Because why people are fond of concrete? It is the most produced product with very important material called cement. Right? So cement, why cement is important? We may have lots of statistics. To summarize everything in a simple manner, cement is the most consumed commodity next to the water globally. So by this statement, you can understand the impact and the importance of cement. Okay. So cement we cannot leave out because we need cement. But the point is how eco-friendly you try to alter the cement is, right? So ultimately the cement is going to be the gray. Okay. So when we say gray, it holds both goodness and it also it has its own badness, right? So it is going to be gray anyway, but people will not give up, right? So they will keep on putting something into the cement, making a partial replacement, full replacement, making different composition, put it into concrete or mortar or any other product and test it for the standard wise requirement. So by that way, we will never give up on cement. Okay. But the point is, how much left on the earth surface as the sources of the cement. So when you go down, deeper down, what is made up of cement as a product? Again, some clay and sand and some processes. So as long as you have clay, as long as you have sand, you may bring in the production of cement. Okay, how far? Okay, up to 2,250. Okay, what about after that? What about afterwards? You don't have clay anymore on the earth and you don't have any more sand on the earth. Then the cement will become retained. Okay. So till then, people will keep on playing with the cement and concrete continuously. And the market will not stop for any of your experiment. Market will keep on running. So that only nobody cares about what this particular research is all about. Okay, we are a concrete producer or a cement producer. Let us wait for this group of researchers who is working one corner of the world. They may come up with the alternative for cement. No such manufacturer of cement will wait for it. They will keep on producing cement. They will keep on producing concrete, and they will keep on enhancing the infrastructure. Right. So we can't stop the market. So we parallelly work and we parallelly measure things and we parallelly optimize things. Right. So when the parallel optimization and the actual production meets together, there will be the original or real net zero may occur. Until then, net zero will become only the part of the documents, but not in the real practice. Right. So here we have these two routes, product wise, building wise. You can do carbon footprint for a product and also for a building. So now we have the tools, right? So lots and lots of tools are there. It's all up to how far you have explored them. That's all, right? So here, this is the route we have mentioned. So let us take that first one, product level. So product level, when you want to do carbon footprint measurement, again, we have a classes. Okay, whether you want to measure the whole life carbon or only the embodied carbon. So when we say whole life carbon, it is the construction, transportation, production, transportation, construction, use phase, end of life phase, everything put together, whole life carbon. When we say embodied carbon, it is only cradle to gate. Okay, mining, upstream transportation, manufacturing. That is what embodied carbon. Okay, so when you want to do embodied carbon measurement, there are lots and lots of tools out there. So we can say build carbon neutral, kaleidoscope, Calumen glass calculator, and some mobile-based applications are also there. So for a mobile-based application, I can say there is an app, Android app, which is called ID Mat Lite LCA. Okay, so which is developed by Delft University of Technology at Netherlands, located in Netherlands. They are very popular for the construction-based sustainability areas. So they developed the software, and very importantly, that app is freely available in Android, and you can see lots of Indian-based materials there. Okay, so make use of that in case of any small project, right? So embodied carbon tools. On the other hand, whole life carbon. So if you want to measure whole life carbon, then you can do manually. You can really do manually, and you can also use a software, right? Predominantly one-click LCA, right? On the other hand, this is for carbon measurement, right? For a carbon measurement. On the other hand, environmental measurement for a product level, we can say lots of LCA softwares, Open LCA, SimaPro, again one-click LCA, Spera. Spera is nothing but earlier it was called as Gabi, so now it has been renamed into Spera. Spera LCA for experts is their software name. Okay, so being an education institution, you can look for the educational free license from them. Spera is available, but SimaPro has stopped educational license, free license for India since last December. Okay, so they completely stopped because they merged themselves along with one-click LCA as a duo company. So they stopped their free offering. Okay, so that is the reason. On the other hand, building level. So whenever we say building level, either it is a carbon footprint or a full-scale environmental footprint. We have one-click LCA, right? Globally preferable and globally popular. On the other hand, Athena impact estimator for buildings is available, but that is only restricted for the American region. So if you open that Athena software, which is a free one, and it will first ask, okay, which is your location? Only the American region should be available in the list. Right, but for educational, project level things, you can use them, right? So no matter whatever the location it belongs to, right? So you can see one-click LCA here and there. So I would like to state here a very important point. If at all, if you want to work in buildings related, construction related, sustainability areas, you need one-click LCA. Because they are growing in that way as a bigger and very bigger monopoly in a global market. There is no other option for a well-versed, for a very quick and for a comprehensive LCA study for a building. You should have one-click LCA. Okay, but the license cost is very, very higher. That's a different aspect. But you don't need to work towards any other tool. One-click LCA, just stick on to one-click LCA. They have their own one-click LCA academy. They offer lots of free courses, talk only about their tool. So you can jump in and you can learn on your own basis. Okay. So in other words, you can say like one-click LCA is like Anirudh. Anirudh, music director from Tamil industry, wherever he, composes for a movie, he doesn't sit quiet. He would put his mouth in every song here and there, right? So that way, this one-click LCA guy is like Anirudh in the construction area. Okay, so no matter whatever you do in the construction, in the name of sustainability, one-click LCA will jump in and will say, yes, I'm here, like this. Right? So please go and explore that one-click LCA tool. and understand what are the capabilities of that tool and why it is important. Because they have become compliant for most of the global countries' requirements, individual countries' requirement. Especially you people from Kerala used to go to UAE straight away after you graduate. So in the entire GCC area, whatever the country specific, for example, UAE, Qatar, Saudi Arabia, whatever they have, their national specific requirement is already compliant for one-click LCA. So they just refer to one-click LCA as a textbook reference. Okay, so you take Saudi Arabia, for example, Qatar, for example, they have already started mandatory to perform whole building LCA for initial approval itself, right? But UAE is not in that point anymore yet, so they may come to that point soon. But Qatar is on the front end, then Saudi Arabia is on the another front end. Then slowly other areas like Yemen and other regions and UAE is following, right? So please, think about one-click LCA in your free time, right? So demonstrations, right? So now we have lots of options. We have carbon footprint related tools, LCA related tools, right? So let us explore as much as possible, right? I hope the screen is visible. Any question for anyone before moving into the demonstration? Any question for anyone? Am I audible?
Yes, sir.
Yes, sir.
Yes, fine. So that's great. So first thing I would like to show you is circular ecology website. So this is a UK-based organization who is taking care of generalizing or publishing embodied carbon information of construction materials, right? UK specific, but still, since no other country have such a broad coverage of materials for the embodied carbon factor values, we anonymously follow these values. Okay, so you can see lots of information about construction like LCA and other things. So explore this website as a whole, and you can see one thing, ICE database, right? So ICE database, you can see it like this, right? Database control. Yes. So what is that ICE? Inventory of carbon and energy. Okay, so you can see most of the construction materials and popular construction materials and their embodied carbon values. Embodied carbon values will be available in their database. So once you just fill up all the thing, you can download as a Excel sheet, right? And they will be looking like this. So ICE, that's the current version, okay, October 2025. So it's a full Excel sheet classified into different tabs for different materials. You can see everything here. And when you see the different tabs, you can see this is a tab for aggregates and sand. And when you just scroll down, you can see for very descriptive product, what is the embodied carbon, kg CO2 equivalent per kg, right? And respective data quality scoring also they have given, which is very, very important in case of if you are looking this for a research paper publication or PG thesis or PhD thesis, right? So lots of options will be. So for sand, completely. Then aluminum, you can see aluminum as a product. Lots of divisions and different values. Then asphalt, similarly, asphalt related products. And bitumen, and very importantly, cements and mortar, because we would be fond of cement always, right? Different classes of cement, types of cement, everything. Now you may wonder, okay, sir, I want to have fly ash based cement. That also would be available. You can explore this sheet. right? Then you have ceramic, you have clay bricks and concrete exclusively, right? Concrete. And when we say concrete, obviously, right, it's a different classes. So, with respect to each and every descriptive thing, it will be given for each strength-wise mix, the respective footprint will be available. So, how you can directly make use of this? You would have already calculated your mix proportion. And for that mix proportion, you will have the value. Okay, cement to this much quantity, sand, water, everything. And for each of that material, this per kg carbon factor, you just take it from this and multiply with your quantity. That is your carbon footprint. And when you sum up all the values, that is the total carbon footprint of your concrete mix. So likewise, whatever the building materials you want to consider, you can calculate the carbon embodied carbon values here. Okay, so glass, insulation materials, right, plaster, rubber, steel, right, timber, and I think some vinyl based things. Mostly it would be covered, right? When you just scroll down and see all the values in it, right? So that is your first tool, and if it is a free one, please make use of it, right? Next one is page. Second one is kaleidoscope, right? Kaleidoscope, yes, kaleidoscope. You can Google it as kaleidoscope embodied carbon. Okay, it will show up like this. And what is the highlight of this? This will provide you embodied carbon for the different components of a building. Right? So it can be envelope, insulation, partition, wall, ceiling, flooring, like this. Okay. So you can read the website. And for example, let us take wall. Okay. When you click wall, you will have the option. Simply, you just need to select it. That's all. By parallel, it will calculate the thing. So what is the impact you want to see? Only GWP or all the impacts? Okay, all the impacts will be coming: global warming, non-renewable, eutrophication, smog, acidification, ODP, everything, right? Then life cycle stage wise, material breakdown, right? So for example, okay, life cycle thing also, lifespan also is available 60 year and only module A. This is only embodied carbon, this is whole life carbon. Okay, that's the point. So here is the options, wall finish type. So let us just clear everything. Okay, so our choice. Okay, let us go with aluminum panel. And the description is available. You just check that. So aluminum panel. So wall production. That is your GWP of aluminum panel. What's that? 8.55 kg CO2. That's all. That is the value that you need. Okay. Along with that aluminum panel, if you have a steel sheet, this is how it will get added. So it's up to your different combinations. You can simply make a small project. Okay, make some 5 different compositions and understand which is the lowest one, and try to understand why it is a lower one, so that you can understand the materials in a sustainable perspective, sustainability perspective, right? So cementitious wooden panel, no, very bigger number, right? 13. No, it's not 13. It is 1.34. And also you should understand the unit of measurement, kg CO2 equivalent per square feet, right? So that you should understand. So likewise, yeah, here it is. So we have the option, right? Different option you can choose. Put the square foot value and the GWP will be automatically calculated. And you can compare with, okay, this thing, okay, 5 square feet. Same 5 square feet, but 2 different materials. Can you see the difference? PVC, free rigid sheet, and aluminum panel. That's the difference. Aluminum is a worst product. So against textile, you can, it's like a equal, almost equal. PVC fairly rigid sheet against the textile product. So likewise, you can do a lot of modifications and understanding for a wall system. Okay, and you can generate your option in form of a PDF option as well, right? And you can document and you can save for your later reference in that, right? Similarly, you can do the same thing with your sealing different sealing options and all the things, right? So that is your kaleidoscope embodied carbon design tool. So what is the use of this, sir? You are simply selecting and seeing what is the use, what is the application. So these and all would be useful for the initial screening. You may have multiple options to pursue. Okay, which one I want to go with? Why? Because ultimately putting in a single term, how we have financial budgeting for a construction project. Similarly, a concept called carbon budgeting is emerging. What is a carbon budgeting? Initially, we will have, okay, sir, my budget is 10 lakhs. For the 10 lakhs, I want to construct 2 BHK. What is the possibility? That is how we discuss, right? So now for a larger construction, especially as I said in the GCC area, Qatar and Saudi Arabia governments, what they are telling, when you start preparing the financial budgeting for your construction project, you also come along with the carbon budget, which means they say my construction project budget is 10 lakh rupees. Also, my carbon budget is 400 kg CO2 equivalent per meter square of my construction. So for the 10 lakh rupees, I may come up with a different grass floor area, isn't it? Depending on different plan, different architectural elevations, everything. But the financial budget is 10 lakh. At one fine point, you will need to lock down your grass floor area. Okay, this is the grass floor area I want to construct. Okay, for that grass floor area per meter square, your material selection should not exceed 400 kg CO2 equivalent in terms of global warming potential. So now, at that point, you will need these kind of tools and calculators. Okay, I really don't know what is the GWP of my material option A and material option B for a flooring. Okay, so you can come here and you can understand, okay, what is the typical types of flooring available. Okay, all these are flooring type, granite, everything, right? I really don't know what a granite GWP may be or what an epoxy based flooring may be. So that I just for a benchmarking, you can do this. Okay, you can understand. Okay, epoxy, you may think it's a plastic, so it may be higher, but unfortunately, it is a lower on the other. So very lower, 0.84 kg CO2 equivalent per square feet. And if you take granite, it's a bigger than, because it's a stone based, lots and lots of activities are happening. So it's a bigger fit. So the screening activity can be executed with the help of these kind of tools, right? So that's the second tool. Third tool I want to show for the exclusive one for glass element calculator, right? Element glass calculator. So it's exclusive tool for Saint-Gobain. And I don't know whether you people know or not. Saint-Gobain is a global glass manufacturer and also a global leader in the sustainability. Why I say lots and lots of glass manufacturers are there globally, but these people are very, very way ahead in the sustainability. And they have their R&D unit in IIT Madras in Chennai, and they have published more number of EPDs than by any glass producers in the world, right? So they have released their own glass calculator tool for free, right? So you just need to log in or create account using your official mail ID. Just log in. So what is the purpose of this? Again, if you take a building and if you do the LCA, there are different elements would contribute to the maximum number of GWP, right? So which would be the more contributing or more commonly contributor for a building? So is it beams or columns or flooring? Any idea for anyone? So you just make use of your mail ID, and once you come in, this is how it will appear, and you can see options in the left side. Configure a glassing, right? So in case of commercial building, glassing is one of the top 3 contributor of your GWP, right? Commercial building. So when I say commercial building, it's like, the mall, the office buildings, IT park, all those things you can understand that, right? Okay, so when you click configure a glassing, this is how it will appear. So you can see that, okay, this is a double glazing. No, it's a single glazing. So this is outdoor and this is indoor, so that you can understand. Okay, so in center, so now the outdoor glass is being selected. So what you want to choose? Different models from the same domain would be listed, right? You can choose. And what is the thickness of the glass you want? You can choose. And what's the thermal kind of treatment you need? Annealed, tempered, or heat strengthened? Which one? Whether you want to have a lamination. If you click this, it will add another layer automatically, right? This layer will come up. And this substrate again, and this is a empty area, right? Cavity. So that cavity can be simply air or a specific gas. So which has a different thermal ingress property, so that you will still receive the sunlight through the glassing, but not the heat. Okay, so that is the different options you have the cavity, and different options are available. So after choosing your number of things, the right side you can see compute performance. When you click that, it will compute the performance for the chosen configuration. And at the bottom, you can see global warming potential A1 to A3, right? So here it is not available, right? I don't know why. You need to choose the different values. Sometimes for a weird kind of configuration, you are not able to see the value. So there, it's not available. Let me show it. Sometimes it happens, no issues. But this is where you can do the trial and error for your glassing product selection, right? Okay, so it is not showing here. On the other hand, let me show here. Find a solution. Here, find a solution. Find by performance. Yeah, sometimes the software will be down, but still we have another option. Find a solution. You can click, and you can choose by country. Okay, unfortunately, India is not there, but still, right? You can see from where the production or the import happens, right? So standard by default, it will choose the standard itself. So what is your building type? Office building. What kind of glazing you want to have? Double glazing or triple glazing? So if I choose triple glazing and click validate, it will show. Okay. Solar production standard, visual comfort, acoustics. Okay, everything. But unfortunately, yes, okay. There is 3 options available. Discover proposals. Okay. Performance mode also you can adjust manually, right? But standard thing is chosen. So 3 options are available, right? So when you click that, all the three options will be listed here. So take a note of time. So three different models, right? Option 1, option 2, option 3. So what you can do some lots of statistical things here, and the respective configuration is mentioned here: outdoor, indoor, triple glazing we chosen, right? So triple glazing. So the model name will be there, and you can see download product sheet. You understand this is exclusively for the same domain products alone. Okay, so when you download the product sheet, this is what comes out, and under the sustainability, you can see carbon footprint. European average is 83 kg CO2 equivalent. So if you want to purchase 3 triple glazing, this particular model comes with 83 kg CO2 equivalent per meter square. That's the thing, right? So like this, you can explore the different options in the same domain for your glazing solutions, right? And you can put your own configurator and you can ask for the respective model also. Okay, this is the product we want. Like this, actually, you can forward it to your procurement team, right? So that is your column. Then we have open LCA, right? So open LCA is for product level life cycle assessment, a full life cycle assessment. So whatever we have seen so far is a carbon footprint measurement product level. Okay, and this is full environmental measurement for a product level. So when we say full environmental measurement for a product level, we have multiple options: Open LCA, SIMA Pro, GABI, Conclave LCA again, and Echo Chain, Carbon Graph. Lots of products are available, softwares are available. So depends on the cost and it depends on the favoritism you can purchase on your own. For educational institutions, lots and lots of offers would be available from each of the provider. You can explore them, right? For example, let me show you a quick model of a conventional brick and a eco brick. Okay, eco brick. So when we say conventional brick, lots of options are there. Eco brick, lots of options are there, right? But still, right? So one particular combination we have here. Right? Eco brick, clay brick. Okay. So here's the clay brick. So I have splitted the clay brick into life cycle stage A1, A2, A3. I hope the screen is visible, right? So when we are modeling in the LCA software, we have option. You can put every data into a single process and you can model, or you can split your data into a life cycle stages. So I used to follow the second option. So I splitted the data into 3 different stages: A1, A2, A3. Okay, A1 is raw material. A2 is raw material upstream transportation towards the factory. A3 is actual manufacturing. That's all, cradle to gate. Okay. So when you just open A1 raw material, which I have already done, just I'm showing it for understanding. I think somebody is playing on the screen. Okay, how I can remove this? Somebody put a plus symbol. What does that mean? Okay, fine. Thank you. Right. So as you see, this is A1 raw materials. What are the raw materials? Some chlorine liquid, clay, some diesel burning, electricity, metal working, natural gas, sand, tap water. Right. All these are required for your the raw material preparation for clay brick. So you may wonder why electricity is being added here. So that electricity is added for that infrastructure requirement. So it's all depend on your system boundary, what you want to include, what you don't want to include. Accordingly, you can change that. Okay. So in this case, this is what I have included. Okay. So likewise, you can take any product, cement, concrete. So you just break down that product into the further level of constituencies. For all the constituencies, you just add them in the software and attach the background data set. That's all. Okay. Likewise, A2. If you see the A2, it will be showing only the transportation. Transportation of different things, different items. Okay, 4 different items in terms of ton kilometer. So when we add the transportation data, the unit of measurement will be mass multiplied distance. That is how it will be calculated. Right. Then in the A3, you have it here, electricity and natural gas and some emissions and wastewater in the output section. You can see damaged brick material, some wastewater, some CO2 emission, nitrogen oxide emission, right? That's all. Once you just added this, you can convert it into a product system, and the product system will be looking like this. This. Right. So the product system for A1 raw material and A2 of the raw material and A3 of the clay brick manufacturing. Okay. So inputs, outputs, emission, and wastewater going for the treatment. Right. So now we can go for the calculation of the full LCA result for individual life cycle stage. I want to do it for A3. Okay. So it's calculate. So when you calculate, click calculate, you will have the option which assessment method you want to choose, you want to apply. Right. So if you want to calculate only the carbon footprint, then you choose IPCC 2021. No, I want to do for a whole environmental damages means you choose any other option. Okay, so Tracy is meant for America, and European EF 3.1 is meant for European region, right? Choose European region and just click finish. So the LCA is getting conducted, and you will see the result, right? And the result is only meant for the A3 of the life cycle stage. Okay, so that you should understand. So this is the typical result. So climate change 206.46 kg CO2 equivalent, land use 129, and water use potential so and so many people. Then ozone depletion, then eutrophication of different categories, ecotoxicity. This is your full LCA. So this is only for the A3. Similarly, you perform the calculation for A1, A2, then you just add all of them together. That will be the whole values of each impact category for your entire brick manufacturing, clay brick manufacturing. Okay. Similarly, we have the eco brick product system also. So just for your understanding, let me show the comparison. So clay brick versus eco brick. This is already done. So we just do the calculation. So here you can see a comparative result. The life cycle stage wise impact between clay brick A1, A2, A3 and eco brick A1, A2 and A3. So in the report, you can see it visually. This claim change. This is it. So you can see clear brick A1, clear brick A2, clear brick A3, and echo brick A1 into A3. And you can see full impact category wise result. Right. So this is how we can perform the life cycle assessment in open LCA. I think the time is enough, but still lots and lots of tools are there. You please explore and go. I can share some of the list to your professor so that he can forward it to you and you can explore them on your own. Okay. So there is a free tool from same circular ecology for a concrete mix. For every typical concrete mix, you can perform the carbon measurement. And you can make use of these in your projects, in your research papers, or any of your competitions. And you can cultivate your skill of sustainability assessment of construction materials. Okay, you can put it boldly in your resume, right? So that will add lots of value in your job market scenarios. So finally, if you want to become LCA expert, okay. No, sir, I'm a very beginner. No matter. I suggest you to follow these 3 organizations. Okay, globally speaking. ACLCA, American Center for Life Cycle Assessment, that is the only professional body exists in the entire global, predominantly, trustable. Okay, Americans and American guys, right? So American Center for Life Cycle Assessment. The second one is Eco Platform, Germany based. And they are very, very peculiar about construction sector and the product level sustainability, building level sustainability. You just follow their website, go and put your mail ID, subscribe for their newsletters and get to know about them regularly, right? Then finally, One Click LCA, as I mentioned, that guy is the Anirudh of your construction sector, sustainability assessment. He will become monopoly, or he has already become a monopoly in that region, in that industry, right? So no matter after your graduation, you want to work in any part of the world, including America, Europe, and Asia, I'm saying, okay, including obviously the Middle East. For the construction sector related sustainability requirements, One Click LCA is a predominant solution. So you learn, right? So that's the thing. And final key takeaways. So life cycle assessment is a scorecard for a product or a process or a service, right? Indicating environmental damage caused by them. And the impacts can be grouped into either carbon centric or covering the full environmental spectrum. The choice is yours, but sometimes people misunderstand that or miscommunicate that. Sir, I want to understand the environmental impact, but coming up with only the carbon footprint. But they are not distinguishing it. They believe that environmental impact assessment is carbon assessment, but it's not. Okay. The knowledge and various open source carbon calculators will definitely help to fasten your decision-making process by doing a screening activity. Okay, this material, this much GWP, that material is that much GWP. Then finally, knowledge on full LCA softwares like OpenLCA, SimaPro, Gabby, or One Click LCA will definitely help you to evaluate the full range of environmental assessment for your given product. So as a entry level market, sir, I am a final year student. What I can focus to get an immediate job within 2 months. Okay, I can say that. If you complete your UG today and the next 2 months, if you want to get into a job, you please enroll yourself under IGBCAP associate exam. I hope your professors definitely would have spoken about that. Get that batch and say, this is my identity card. And parallelly, you please learn about One Click LCA software through lots of boot camps and online courses are there in their free academy. It is completely free. And do some self-practice projects and document it. Very importantly, document it. You can use Cloud AI for a very quick exercise, I can show this. I know time is getting increased, but please give me 5 minutes. So I trust in Cloud AI. Okay, you may have any of your favorite AI tools. So I am just randomly asking. I need a data inventory for a building life cycle assessment. And I am going to use Athena impact estimate. That is a free tool. Okay. Please generate the simple inventory for G+1 office building. Okay. In HTML. Right. So we say this, and this guy will do the rest of it, and it will take a very few moments, and it will generate the inventory that you want. So inventory, when I say, it is your data. Okay. So that data you can take from this guy, and you take that open source LCA tool, impact assessment tool, Athena, and you just feed it there, and you perform the result and take it out as a PDF document. And you can make a full report of your inventory and the result and your tool. And you can have a booklet. Okay, this is my self project number 1. Performing a life cycle assessment of a building using so and so. So this will definitely make you employable within 2 months after you getting completed your UG degree. So if at all, if you want to enter into a construction related sustainability job markets, right? So it's lots and lots of there, and it's keep on emerging, right? And along with that, I would like to state one final suggestion. Please be active in LinkedIn or LinkedIn, whatever it is, right? So that's how I have built my company. Only LinkedIn. Okay, if tomorrow LinkedIn is got hacked by some alien people, I will be jobless, right? So entire thing is LinkedIn, and it's completely free. That's the best part of it. You simply connect with your peers and what you want to become. Already lots of people are there in such roles. Just connect with them, talk to them, and just follow them, what they are doing, what they are commenting, what they are talking. Just understand, right? So LinkedIn is a very, very beautiful platform. If at all, if you want to get placed within 2 months, you just follow these things, right? So since I asked it in a HTML, it is taking time, I think. I should have asked. Let me stop it. Without HTML, just and this Cloud monthly subscription is $17, some 2,500, right? You can spend it for some 6 months until you get your job. Okay. So afterwards, you don't need to have a subscription machine. So this is what the inventory I was speaking about. So you have the entire inventory for a G+1 building, right? For a different assembly, different materials and respective quantity. That's all. That's what you need to jump into a software, right? You can copy it from here and you can put it in the software and you can go for the result, right? So I think that was more than enough. And yes, thank you. Thank you for the session and time. Yeah.
Thank you so much, sir, for the wonderful session. If the participants have any doubt, please ask now.
How can I download data for software? I think I just showed that, right? You can simply ask any AI, it will generate. And you can document as it is. This is the AI generated data, and this is the result. And to impress your recruiters, you can create your Google folder, Google Drive, a folder, sample projects, and you can put a complete report of all your projects into the folder and get the copy link for the folder and paste it in your resume or in the form of a QR code. That's all. So that will make you more credible in the work area. Let people will trust you more. Is any further question? Thank you.
Okay, sir. Now I would like to invite Dr. Vinci Verghese, Associate Professor, Department of Civil Engineering, to convey the words of thanks. Ma'am, over to you.
Good afternoon, respected speaker and dear participants. I am here to express vote of thanks to Mr. Sharavanan Jayabharadi, founder and senior sustainability engineer, Carbon Figure Academy, for being here with all of us and spending his time and explaining on the LCA tools. He started with the need and stressing the need for the LCA and importance of LCA, and explained different tools and demonstrated open LCA in the brief time he got. And also he concluded by saying that the different that one should follow the different organizations one should follow to complete the LCA. And also he was humble enough to even show the working how to get the data in using Claude AI. Thank you, sir. It was very informative. Thank you once again for the session.
Thank you. Thank you. Thank you for the opportunity.
Thank you, sir. Thank you, ma'am. Now, as we move to the end of this enriching 5-day online faculty development program on integrated green construction and life cycle assessment organized by Department of Civil Engineering, Jyothi Engineering College, we move into the valedictory ceremony. It has truly been a meaningful and insightful journey over the past 5 days with a valuable session and active participation from all of you. To begin the valedictory session, I would like to invite our respected head of the department, Dr. Alvin Verghese, to address the gathering. Sir, I kindly request you to share your words.
Yeah, good afternoon to all respected dignitaries, resource persons, faculty members, research scholars, and dear participants. As the head of the Department of Civil Engineering, I am pleased to address you during this validation session of the 5-day faculty development program on integrated green construction and life cycle assessment. Over the past 5 days, the FDP has provided an excellent platform to knowledge sharing, and professional development. The sessions and comprehensively covered important areas such as IGBC certification, life cycle assessment, circular economy concepts, NBA accreditation, norms, and sustainable construction practices. The program was carefully structured, beginning with the fundamental concepts and progressing towards advanced tools, applications, research perspectives. This has ensured a balanced learning experience combining with both theory and practical insights. As a part of the validation process, we have to conduct assessment activities, include participant reflections and feedback collections. It's coming. There's also a good idea to validate. There is special thanks for coordinating the coordinators. The responses up to today clearly indicate active participation and strong understanding of the key topics covered during the program. That reflects an effectiveness of the sessions and commitment of all participants. It is also encouraging to note that FDP victims participation from more than around 200 attendees across various states in India. Around 20 plus states are representing as the participants, and also international locations also available over here. I am very happy to say this, making it is a truly diverse and enriching academic interaction. I would like to express my sincere gratitude to all our distinguished resource persons for their valuable contributions. I also extend my heartfelt thanks to all the management team of Jyothi Engineering College, Thrissur, Kerala, and staff members of the Civil Engineering Department of Jyothi Engineering College, for their dedicated efforts and organizing this program. To all the participants, I sincerely appreciate your active involvement and enthusiasm throughout the FDP. I encourage you to carry forward to knowledge gained here into your teaching, research, or professional practices, particularly in promoting sustainable and green construction approaches. I would also like to inform all participants that the certificates of participation will be sent to your registered mail IDs within 1 week, as per the name and details provided during the registration. With this, I conclude my validation remarks and now hand over the session to the coordinators, especially a special thanks to Jeffy and Alpha for the proceedings, and thank you all.
Thank you so much, sir, for your valuable words and encouragement. Now, we would like to hear from our participants. If anyone would like to share their feedback or experience about this FTP, you are most welcome.
Hello. Hello,
Hello,
ma'am.
sir.
May I
Yes, sir.
audible, ma'am?
Yes, sir.
Ma'am, I am A.K.M. Tohidur Alam Khan from Chittagong University of Engineering and Technology. I am working as a PhD research fellow here. So it was a truly informative and inspiring knowledge sharing event. And I have really learned a lot of contemporary research aspects from this knowledge event. It is really encouraging program, and I have learned a lot of things which will be definitely flourish my future research endeavor. So please keep me in your magical knowledge trust and kindly inform me if similar type of event will arrange in future. Thank you very much, ma'am. It was a nice session, ma'am. Thank you very much.
Thank you, sir. Thank you so much. Anyone else?
Good evening. I think I'm audible.
Yes, ma'am.
So I'm Kripa from Ahalya School of Engineering and Technology, presently the research scholar in JC Thrissur. So according to me, this is an immense pleasure to be a part of this very good faculty development program, because we were engaged with many enriching perspectives of sustainable constructions, then LCAs and other methodologies. So the session, for me, it provided a comprehensive understanding of your integrated green construction, then life cycle assessment, then about durability. Many practical approaches was told. And I sincerely thank the organizers and the resource persons for this well-balanced program, which was combined with technical depth and practical relevance. And this is like, it strengthened each of us to move from some conventional construction to an environmental friendly construction approaches. This is a transformative experience. Thank you so much for organizing such a beautiful, wonderful program with a very good time limits. You are doing it very well. Thank you so much.
Thank you so much, ma'am, for your feedback. If anyone else willing to give a feedback, please. All right. Thank you once again. On behalf of the organizing team, we would like to express our heartfelt gratitude to the management for their continued support and to our respected HOD, Dr. Alvin Verghese, sir, for his guidance throughout this program. We also extend our sincere thanks to all the resource persons, our faculty members, staff of Department of Civil Engineering for their efforts in making this FDP a grand success. A very special thanks to all our participants for your active involvement, enthusiasm, and commitment over this 5 days. I, along with my co-coordinator, Mr. Alfred George, sincerely thank each and every one of you for being a part of this program. Now we would like to inform you that the online participation certificates will be issued within 2 weeks and it will be sent to your registered email IDs. Once again, thank you all for your support and participation. With this, we officially conclude the 5-day online FDP on integrated green construction and life cycle assessment. Thank you all. Have a great day ahead. Thank you.